Hi, I'm Dr. Kenyon. I'm looking forward to talking to you about sorting arrays. There are two ways that we're going to sort arrays today. The bubble sort is a pretty simple sort that's really easy to understand. Then we're going to move into the quick sort, which is far more complicated yet far more efficient. Since we haven't worked together, I want to make sure we have the same understanding of definitions of terms. So give me a moment just to make sure we're on the same page there. Certainly you've used variables in math. So when you're programming, you might have a variable x. You might say x equals 14 to put the value 14 into the x variable. I think of a variable as like my home address. I have one mailbox and it has one value for my house. You might use the assignment statement salary equals salary times 1.05 if you wanted to give someone a raise. You might have the statement salary equals salary plus 10 if you wanted to give them a $10 raise. Now as an aside, that's not really an equal sign, right? It's really becomes. I have a mathematician for a wife, so I would have to say, if you have the assignment statement salary equals salary plus 10, you could, if that was an equal sign, subtract salary from both sides. Therefore, 0 equals 10. So obviously it's not a math statement. It's an assignment. When I write my own programming language, it's going to be salary becomes salary plus 10. All right, so that's a variable. It contains one value. Now think about a motel. It has one address, but many sub-addresses, many sub-mailboxes. So the variable might be motel sub 1, motel sub 2, motel sub 3. That would be an array, also called a subscripted variable. So we're going to be talking about subscripted variables or arrays, and with loops we can traverse the array going up and back. When I was sharing this conversation with a colleague of mine, they said, well, who cares about sorting? Why is that important? Quick example, real life. It was an hour before graduation. I was there early as faculty. The individual who had the big box of diplomas tripped, dropped the diplomas everywhere. We had 1 hour to get these diplomas in alphabetical order. Fortunately, there were only 80. If you had 1,000 diplomas, you could see where that would be pretty urgent to have a very efficient sorting mechanism. One of the things we're going to do a great deal in this process is swap values, or switch, or flip. So if I have an egg in one hand and an egg in another, or you might call that card sub 1, card sub 2, how am I going to switch them? Because I can only have one value in each hand. Well, if I was a good juggler, I would throw one up in the air, and then I would flip to the other hand, and I would catch the other egg, right? Well, I'm not a good juggler, so I'm not going to try that. But if you think about it as throwing it up into a temporary position, so you make a copy of that in a temporary position, copy one value, card sub n to n plus 1, and then reassign that temp to card sub n. So that's how you would flip it. Throw one into the temp, copy it over, switch them back, and that's how you're going to swap them. So there's the code for that. And this is just pseudocode. This is not carefully written Java code or Python. Okay, so we know about swapping. We know what an array is. Let's do the simpler one first, the bubble sort. So I'm going to use cards for this. So I'm just going to put these in some random kind of order, just however the cards come out. And this is the bubble sort. Okay. We want to sort these cards in order. Okay. And my knife, perhaps n, is going to start at 1. And the knife is going to move across. Okay. Think of it as a loop. All right. So what we're going to ask ourselves time and again is card sub n, is it less than card sub n plus 1? Is it less? Yes. Then swap using the mechanism before. Move the knife. Is card sub n less than n plus 1? Yes. Swap. Is it less? No. Leave it alone. Is it less? Yes. Is it less? Yes. Swap. Is it less? Yes. Swap. Okay. So the first iteration, we moved the least number to the far right. So that's why it's called bubbling. It's like the least one bubbles up. Let's do this again. N becomes 1. Is card sub n less than n plus 1? Yes. Is it less than the neighbor? No. Is it less than the next one? Yes. Is it less than the next one? Yes. No. Yes. Yes. Okay, so the second iteration, we have the second least number in the second position. Alright, you see the pattern. We do it again. Is this less than this? No. Is 5 less than 6? Yes. 5 less than 7? Yes. 5 less than 4? No. 4 less than 10? Yes. 4 less than 9? Yes. Now you can imagine we don't really have the knife go all 8 positions, because we know the first time we've succeeded on the first one. So a more efficient bit of code, you would go n factorial. So we'll do it again. Is 8 less than 6? No. 6 less than 7? Yes. No. Yes. 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 Whoops. That's a no. Okay. So we got those in position. All right. So you see how this is working. Is this less than this? No. No. Yes. Yes. No, 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 no. Is this less than this? No. Yes. Yes. Start over. This less than this? Yes. Is 8 less than 9? Yes. No, 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 no. We now have them all in order. And here is the pseudocode. Just, again, very loose code. What did we do time and again? We said, is C sub n less than C sub n plus 1? If so, swap. Continue doing that until there are no more swaps, which would probably be a Boolean value. Alright, that's the bubble sort. Very easy to understand, very clear. You can see that the least one bubbles up each time. Okay. Not efficient, but easy to understand. Now let's talk about the quick sort. Quick sort, let's just put some random cards out here. Similar in some ways, but we need more silverware. We're going to put the spoon at position 0. We're going to put the knife, again, at position 1. Now, we need to identify one of the cards as the pivot. What's a pivot? If you think of a seesaw, that's the way to envision it. The pivot's going to be where it teeters, and all the numbers to the left of the pivot we want to be smaller than the pivot, and all the numbers to the right of the pivot we want to be larger than the pivot. For this situation, we're going to call the fork the pivot. So our pivot is 4. Okay. Fork is pointing at the pivot. Algorithm is very similar. Is card sub knife less than card sub fork? No. Do nothing. Move the knife. Is card sub knife less than card sub fork? Yes. Instruction is move the spoon, switch the spoon with the knife, sub-spoon with sub-knife. Okay. Move the knife. Is card sub-knife less than card sub-fork? 1 is less than 4. Yes. Move the spoon, switch the spoon and the knife. Okay. Move the knife. Is card sub knife less than card sub fork? No. Leave it alone. Move the knife. Is card sub knife less than sub fork? No. Leave it alone. Is card sub knife less than card sub fork? Yes. Move the spoon. Swap spoon with knife. Move the knife. Is card sub knife less than card sub fork? No. We've reached the end. We're done. Now what we need to do is put card sub fork, the pivot, into card sub spoon plus 1. Spoon plus 1. So we're going to slide these folks over. We're going to place this into spoon plus 1. Have we done it? There's the pivot. Everything to the left is less than the pivot. Everything to the right is more than the pivot. And we've done the first sweep. Now this is a recursive function. So what we do is the exact same process on either side. We partition the array to 2 parts. And we continue this process until there aren't any further swaps. So today we've learned how to do a bubble sort. We've learned how to do a quick sort. We know how to swap the cells. And I appreciate your attention, and I look forward to the next class with you.